and welcome everyone to a brand new episode of the IEEEtalk podcast. I am your host, Yasmina Kenzari, and today we're exploring another fascinating field, a field that controls quite literally everything, control engineering. But what does it really mean to control a person? A system. To answer this question and to explore this field, we have a very special guest. He used to be a student at IEEEtalk, and now he is a professor here. We all appreciate, admire, and respect. And for control option, he taught us system modeling and identification in the first semester, the one and only Professor Hamza Belmadani. Dr. Belmadani, welcome to IEEEtalk. It's an honor to have you here.
Thank you for having me here. It's a pleasure for me. I had the pleasure of being a student at the Institute. I started school here in 2015. I had a bachelor in electrical and electronics engineering, as usually students do. Then I followed the field of control engineering, and I graduated in 2020. Then I had my PhD at the University of Lida, which was a bit as a combination between control engineering and power engineering. However, most of the work has been at the Institute, although my official PhD administratively was at the University of Lida. So this is it. And as I said, my PhD was a combination of control engineering and power engineering. Why? Because I had a title of control modeling and identification of photovoltaic systems. So it was a bit of a combination of renewable energies and all of that stuff.
That's so interesting and inspiring. Now let's dive deep into control engineering, where technology, mathematics, and innovation comes together. Professor Belmadani, what were some of the biggest challenges you faced in this transition?
Well, you mean the transition of being students to a teacher at the Institute?
Yeah.
Well, actually, being a teacher was a dream from the beginning. So I didn't actually face a lot of issues or problems in this regard. So the main problem was that I followed control engineering during masters. Then PhD, I had to, had some knowledge in power. So there was this transition between control and power engineering, and learn a lot of stuff. So this is the most issue that I have actually faced. It's the transition between control and power. Actually, a lot of students here at the Institute previously think that I am a power engineer because I have taught a lot of power engineering courses and the option of power. So this mix-up between the two was really challenging. Yeah.
That sounds rewarding.
Yeah.
Control engineering is one of the most popular majors at IEEEtalk. Could you introduce this field and its program at the Institute, giving students a clear picture of what to expect?
All right. So the control option at the Institute, as the other options, we had an improvement. We had an update of the program. So we had the green light to change whatever we can change. Now, in the control field, actually it is made up or can be divided into two major orientations. The first orientation is control theory. The second orientation is automation. Yeah. So these are two different things, two different fields, but they collapse down into one major field, which we call control. Now, in control theory, so you had a course in third year about linear control systems. So control theory is about extracting mathematical models for systems, okay? And you try to find a suitable control for that system. And what I mean by suitable controller for the system is to enhance the dynamics of the system. Dynamics means to try to speed up the system if it's slow, improve the steady state error if there is steady state error, And those are the main dynamics that we need to improve in systems. And systems, so we have a lot of variety of topics in this area. So we have robotics, we have also industrial processes, we have motors, and so on and so forth. So we need to improve the dynamics of the system by first you have to model, you have to identify your system, what is it? Okay, so that was the course in the first semester. A mathematical description, which falls into transfer functions, state space, and so on and so forth. Then you have to investigate the performance of your system, investigating the performance, accuracy, speed, so on and so forth. Then once you have investigated the performance, you go into control. So you have now to choose, let's say, a suitable controller. And suitable controller means you have to choose between a trade-off between complexity and accuracy, and so on and so forth. Now, the type of controllers that we usually have, and they are popular in this field, so they start from the basic PID controller, okay, which you have seen in third year in linear control systems. Then there are a bunch of advanced controllers, like the model predictive control, adaptive control, which you will see in the next year. We have nonlinear controllers for nonlinear systems, although PID can work out with nonlinear systems, although it is a linear control. So these are, let's say, in general, the main topics investigated in control theory, the first orientation of this field. The second orientation is automation, Now, automation means to make machines automated. So they do a specific task, repeatedly, And by means of what? By means of some controllers. The major controllers that we use in the industry are PLCs, programmable logic controllers, And programmable logic controllers are, let's say, a simple way to make machines automated. So they are the simplest control that we have in the industry. And they have been improved a lot in recent years. Now, that's about automation. So you make a combination of a PLC, sensors, actuators, and to make the process work repeatedly, repeatedly and in automated manner as you desire it, as you want it to be. Now, you might ask, are these orientations, the two orientations, do they have a common, a common topic or a common piece? Well, yes, there is a common piece. So the two fields share one common piece, because sometimes, for example, if you want to control a motor, let's say an induction motor, it's a system that you can have a model. You can have its state space model and the simulating model, and you want to control them. In the same way, we can control it using the PLC and the variable frequency drive. So here we have two bunch of fields or topics. So we have automation to control the motor, and we can also enhance the dynamics of that motor, using PID controllers, for example. So you can implement a PID controller, which is in control theory. You can implement it in a PLC, which is and collapse down into the automation field. So these are the major, topics investigated in control, and of course, robotics falls also in between, because we have robotics in the industry. If you have a robotic arm, so there are two, let's say, two aspects that you want to investigate in this robotic arm. First, you want a robotic arm that is so accurate, and so fast, for example, in the production line. And that means you need here advanced control techniques. So you need a mathematical model, and you need also to choose a suitable controller, which would be implemented in an embedded system like the DSP and FPGA, or simple Arduino, and so on and so forth. And then this robotic arm, once it is a final product, it will be controlled by a PLC in the industry. A PLC and probably VFDs and motion control systems. Okay, so these are the major topics in control. Now let's talk about the program, okay, that we have updated at the institute. Now previously there was, let's say, an over promotion of mathematics in the program. So the mathematics courses were a lot,
Exactly.
in this program, in the previous program. And what we want to achieve is what? A balance. A balance. Of course, mathematics are important in control theory, and indeed, control theory is can be classified as applied mathematics. It's a field of applied mathematics. But we want to achieve a balance, a good balance between mathematics, control theory, okay, and automation. Now, previously, as I said, mathematics was over promoted along with control theory, but automation was a bit, okay, under promoted. So that's the main goal that we wanted to achieve in the update of this program. So we have removed courses that we really we actually don't need so much, okay, like complex analysis and data structures and algorithms, which is more relevant to computer engineering students, and optimal control. So we have changed the name, okay, into advanced control techniques, and we have made it into two chapters or three, I don't remember actually. So now we have added, let's say, 4 or 5 new courses to the program. So the first course that we have added is
nonlinear systems.
No, nonlinear systems was in M2, in the second year of masters, and now it has been shifted
the first year, yeah.
down into the first year. Also with system identification. It was only system identification in the second year of masters. Now it has been changed into system modeling and identification, because students don't know, okay, how to model complex systems, how to find mathematical descriptions for them. And it has been also shifted down into the first year and first semester. Now, with these removal of courses and the change of locations, so there are gaps.
Yeah.
Okay, so we need to add more courses. So
Like
the first course was applied artificial intelligence. It's very, very important because it is important in data-driven control, which is, let's say, a recent field in control theory. Okay, and we have also added robotics. There was no robotics
For the master too.
Yes, M2. So there are 4 new courses in M2. We have robotics, we have industrial communication networks. Okay, so students will be introduced to basics of networking. Okay, and then they will dive into communication protocols that are used in the industry, like Profibus and Profinet, Fieldbus, so on. The third course is advanced control techniques. Now, the problem with the previous program is that students study nonlinear control systems. Okay, so they study control systems, but they don't really achieve the most important topics due to the shortage of time. Okay, so the semester is so short, so students cannot achieve, okay, or attain the major topics in nonlinear control. So they only study the analysis of nonlinear systems, but they don't study the control of nonlinear systems. So we have taken this into consideration. So I actually pay this attention when I was a student. So we have only studied analysis and not control. So we have added this course of advanced control techniques in the second year to follow up with the analysis of nonlinear systems. So now they study the control of nonlinear systems and a bunch of other control techniques, okay, like sliding node control, backstepping control, and so on and so forth. And of course, optimal control, which was a single course. Now it has been, okay, shorted into 2 chapters, because that's really what the students want to know. Then we have the fourth course, which is adaptive and model predictive control, which are very, very important as advanced control techniques. Of course, they cannot be combined with advanced control techniques in a single course, so they needed to be taught in another course, okay, because it's a wide field, it's a wide topic. So these are the major modifications that we have incorporated into the new program. And of course, we have kept the course of advanced mathematics, which now I think it's advanced mathematics for control.
Yeah.
Yes. So it's important. Linear algebra is important. You can see that in artificial intelligence. You can see that in
it's everywhere.
MIMO systems and in system identification and modeling. So it's everywhere. Okay, so it was really important. And of course, you will study advanced topics in linear algebra, like singular value decomposition, which was supposed to be taught in the first year in linear algebra, but due to the shortage of time, cannot be done. So there should be a single course that covers advanced control, advanced mathematics for control. Yes, and we have actually added that is very important, the course of sensors and actuators. So now previously in the previous program there was only a course which is called industrial instrumentation. Okay, so in industrial instrumentation, students will try to learn both measurement systems, okay, as a system, and sensors as devices, with no knowledge of actuators, which are important in the industry. Now, we have seen this problem, so we said, why not study instrumentation systems alone as systems, as a combination of all the devices that are included in these systems, okay, whether they are sensors or actuators, and the measurement system itself, signal conditioning, filtering. So these are systems. So now the students in the next year will study systems alone. But now they have been taught what sensors and actuators alone in the first year. So now they have knowledge of sensors and actuators. So of course they have seen sensors in third year, but they are not enough. Okay, these are not the only sensors that we have in the industry. So you have studied more sensors, and then you continued to actuators. Okay, so those are the major amendments that we have incorporated into this program.
But was so beneficial. Many students seem to naturally gravitate towards control engineering. Why do you think it is such a popular choice? Do you think that students choose control or control choose students?
Well, that's a hard question. Actually, in my case, I struggled to choose between control and power in my selection. And I think most of students struggle between either power and control or control and computer.
Yeah,
okay,
exactly.
Now, control is actually the most popular, along with power. That's because it's all because of the job industry. So the job industry in this country is all about automation, not control theory. There is no control theory in this country because there are no robotics, no design of systems, yes, only automation. So students, of course, choose what gives them more opportunities, which is automation engineering, instrumentation, which falls into automation, and power engineering. So it's actually a consequence, it's a result. Of course, I'm not neglecting the other options, computer and telecommunications, but this is a fact. The job industry in Algeria is all about automation, instrumentation, and electrical engineering in general, whether it's power or the design of electrical systems or protection, those things. Yes.
What kind of career paths can control engineering students from INELAC pursue after graduation?
Now, the career paths falls into two major orientations again. So they can be automation engineers.
Mm-hmm.
So they will be working with design of automated systems with PLCs, SCADA systems, HMIs. And the second orientation is instrumentation engineering, which is a bit different. So in instrumentation engineering, an instrumentation engineer would actually follow the process of the sensors in the
measurements.
Yes, measurements, whether the sensors are working properly or not. Okay, if they are not working properly, so they need calibration, and calibration is a major topic in instrumentation. And if they are not working properly, they cannot be calibrated, so they need to be changed. And so the process of changing the sensor might need a study if the system is complicated. So in general, you have automation engineering and instrumentation engineering. Okay, and most of them are in the oil and the gas industry.
Yeah.
Yes. Now in the north, of course, there are positions as automation engineering and instrumentation, but the work is not really promising. So they don't really need that much of the technical knowledge, okay, in these fields. So they just need basic knowledge because most of them, they need to fill out some reports, okay, about the performance of these systems, whether automation or sensors. So this is it. And now there is actually new companies, which we call them startups. Okay. Now there is a new field or new orientation, which is the design of PLCs. Okay, so there are actually now startups that are now trying to design their own PLCs instead of
importing them.
Siemens PLCs and Schneider Electric, which are expensive. So why not, design our own PLCs, which is of course a very challenging task.
Okay.
Yeah.
So my next question is, what are the most important technical skills a control engineering student must have?
Now there are a lot of skills, but the major ones you need to know or to advance your knowledge in PLC programming, programmable logic controllers.
Yeah.
You need to advance your knowledge in sensors, working principle, their incorporation into automation systems. So sensors, actuators, okay, these are very important. Now with these, you'll go on into communication protocols because we need communication between PLCs, sensors, and other devices. So the student needs to learn communication protocols that are used in the industry. Okay, and then it needs more. It can advance more into SCADA systems. Okay, which is the total hierarchy of the combination of PLCs and sensors and actuators and all the devices in the production line. So we need to control them as a single entity. Okay, so that's what SCADA stands for. Okay, so these are the major topics. As I said, PLC programming, sensors and actuators, working principle, design, their selection, of course. Because if you have a system, you need, for example, for object detection. For object detection, you have many sensors as choices. Okay, so what is the most suitable sensor for my system, depending on the environment. Okay, is it a harsh environment or is it a simple environment? So it's not only about the working principle, but also about the selection of those sensors and actuators in my environment. And then communication protocols to communicate between all the devices, between PLCs, VFDs, so on and so forth. And then what I said, SCADA, which is comes at the top of them. And there is also an important field or topic in instrumentation, which is piping and instrumentation diagrams. So students need to learn, for a certain system, how things are connected, and for things to be connected to to see the entire system, the overall picture, we need diagrams for that. So there is a specific diagram which we call P and ID diagrams, piping and instrumentation diagrams. So it's very important in your CV, to be learned.
To learn how to read it, or
yes,
how
to learn how to read it in general, because they exist in the industry. So any industry has its own
P and
ID diagrams for specific systems. So the students need only to learn how to read the main connections between those devices.
Apart from technical knowledge, what are the soft skills that help engineers in this field?
Okay, as we have a lot of topics that need to be learned in the automation and control field, students only need to have the passion to learn and the patience in the process of learning. So these are the most important soft skills that need the student to have in order to go anywhere in this field.
That's an inspiring answer. My next question is that many students struggle to choose their specialization. What advice would you give to someone who isn't sure if control engineering is for them?
Well, the first step always is to look at the programs, and not just to look at the programs as the overall pictures. No, they need to go deeply in the content of each course. Now, once you see deeply the content of each course, you will, of course, have, let's say, 60% or 70% of your decision would be already made when you look at the content, because you have already studied before in the third year some pieces of each field. You have studied linear control systems and process control and instrumentation as the major topics in control, and they have also studied energy systems, the electric machines before, and communication circuits, communication principles, computer architectures. So those are a bunch of pieces that fall into each category, into each specialization. So the students' first step is to look at the programs, the content of each course. Then, now the selection, whether it's power and control, whether it's control or computer. Now, power and control have a lot of stuff in common, especially the control of models, for example, or the design of electrical installations for a certain automated system, because an automated system need to be supplied by power. So the design of the electrical installation that supplies power into the automated system is very important. The design is very important, and also the protection of these circuits. So now here, this is a common thing that can be done by either a power engineer or an automation or a control engineer. So here is the trick. Even if you have decided to choose a field, for example, you have decided control, but you are still saying that I might have chosen power. Still, you can follow up with your decision. So you study control, but you can also have trainings in the field of power. There are a lot of training institutes where you can have some practical knowledge. As I said, for example, if you are studying automation and control, what else can be taught in order to complete your CV as both as power engineer as a control engineer? So you need to go more into the design of electrical installations and, for example, the sizing and design of photovoltaic systems, renewable energies. So those all are some stuff that can be learned by an automation engineering student, and they fall majorly into electrical and power engineering. So it's not really late if you feel that you haven't chosen your suitable specialization. If, for example, you have chosen control, But you said along the way, you said, I might have chosen computer. So you can still study how to implement, for example, control algorithms in embedded systems. Embedded system is a major and essential topic in computer. So in this way, you will get acquaintance, some knowledge in the field of computer and embedded systems.
Yeah.
If, for example, you have chosen, let's say, power, and along the way you have said, I might have chosen control. So along the way, you can still have some knowledge about PLCs, because a power engineer can also learn the programming of programmable logic controllers, PLCs, and all of that stuff, because there are a lot, as I said, a lot of training institutes when you can have practical knowledge about them. So still, whether you have chosen the right path for you or not the right path for you, you can still have the knowledge of the specialization that you didn't go into. So it's never late. All right. So this is it. They need to look at the content of each program. So once you have seen the content, I think it's 70% of your decision has already been made, and it's clear, I think. Yeah. Now, along the way, you might struggle, you might face issues. Every student faces issues. Every student might have some suspicion about whether I have chosen the right path or not. It's never late.
Thank you, Dr. Belmadani, for this great answer.
Yeah, thank you.
Finally, what's one thing you wish someone had told you when you were a student making this decision?
Maybe I wish, let's say, episodes like these have been made before, so that I can look at them and maybe I can choose the right path for me. So this is a very good initiative from the club.
Thank you, Dr. Belmadani, and thank you also for your insightful answers.
Thank you for this initiative, and thank you for having me here. It's a pleasure.
The advice of the day is always remember to make good choices. And speaking of choices, it's time for the controlled choices segment. You will have two options, and you have to pick one without thinking. Some of them are easy, and some, well, let's see how we will handle the pressure.
All right.
Which one is more powerful, classical control or modern control?
Well, simplicity for classical control, complexity and accuracy for modern control. So it's up to the system that you are going to control. If the system is complicated, you might need modern control techniques. If the system is simple, you might need a simple PID control. So the selection of the two is, let's say, a hard selection between the two. But I would choose PID as classical control techniques, because although it is simple, it's so accurate, it does the job very well, and it can handle any, let's say, 90% of complicated systems. So I would choose PID.
Which one do you prefer teaching, theory or practical implementation?
Both. I feel that when teaching theory without practical knowledge, I feel like I'm not doing anything. And practical knowledge also without theoretical background is still you cannot advance actually in the field really well. Why? For example, let's say if you are in a developed country, like for example Germany, now they are very advanced in the field of robotics. Now robotics needs a huge background in the theory, simulation, modeling, identification, mathematics. So those are all very important to advance in the field of robotics. So it's very important in order to advance also in the field and the practical knowledge. You need a huge theoretical background. Here in Algeria, you don't need actually much of theoretical background, as let's say everything is imported. Everything is imported, so the devices are ready to be programmed. for example, PLCs. Okay, so I think in Algeria I don't need much of a theoretical background.
So you will choose implementation.
Yes, I will choose implementation. Yes.
Okay.
But as I said, in case of teaching, you have asked me in
Yeah.
case of teaching. When I teach theory without, let's say, a lab, at least simulation, I feel like I'm not doing anything. Okay, so both complement each other.
Okay. If you had to sacrifice one, which would it be? Stability or performance?
Of course, if your system is unstable, you can't control it. You can't do anything about it. So I would choose stability, whether performance is bad or not. Stability comes first.
Sacrifice.
To sacrifice. So
Yeah.
I would sacrifice performance.
Okay.
Because stability comes first. The system needs to be stable first. Okay.
PID control or state space control?
Depends on the system.
You have to choose.
I like state space.
Okay, that's
Okay,
interesting.
Yeah, I like state space more because with state space, of course, there are PID controllers for memory systems.
Yeah.
Okay, but state space is more suitable for multi-variable control systems, and also state space can be used also with CISO systems, with single input and single output systems. So let's say that state space is more general, okay, than PID, so it can be done with both. CISO systems and memory systems.
Okay. Automating a process or controlling it manually with precision?
I would choose controlling the process manually with precision. So with automation there is no precision.
No, there is precision.
So I would choose automating the process.
Okay.
With precision.
Good choices.
Yeah.
But now let's go even faster. Describe control engineering in one word.
Transfer functions.
Why not state space?
Yeah, it can be state space.
Yeah.
Yeah, and it can. You said one word.
One word, yeah.
Transfer functions is two
Yeah.
words, but can be classified.
We can consider it as one word.
Yeah, transfer functions is also a good choice for this question.
If you could create a new rule at any leg that all students must follow, what would it be?
What?
If you could create a new rule at any leg, all students must follow.
Do you mean a new role, like a new rule?
Rule, yeah, a rule that we all have to follow.
That you all have to follow. I mean, I'm actually not a guy that wants a lot of rules in any kind of institution.
Yeah, I can
okay?
tell.
So I feel like the student should have some free time, okay, more free time than teaching time, than studying time, because in its free time, it will investigate more about itself, okay, and it will go more deeply into the field that he wants to be in. So I don't like much rules. So I think that the rules that are already set, they are enough.
That's the most fascinating answer I've ever heard. Thank you.
Thank you.
Describe your students in one word.
Describe what?
Your students.
Smart.
Okay, thank you.
They are smart. And elect students are smart.
That was incredible. Professor Belmadani, it's been truly an honor having you here in IEEEtalk podcast. Thank you for sharing your experiences and knowledge with us. And finally, do you have any final message you want to share with your students?
Well, as I said, the students need to choose wisely their career paths, okay, their main orientations, okay, and they need to go deeper into learning stuff, major topics in the field that they have chosen. So they need to have passion, okay, and they need to have patience, okay, with the field that they have chosen. And as I said before, it's never late. Once you feel that you have selected the wrong path, okay, let's say the less suitable path, it's never late. You can always, okay, start learning stuff from the path that you think it's more suitable for you.
Thank you.
Yeah. Thank you so much.
To our audience, if you enjoyed this episode, don't forget to subscribe, leave a comment, and share it with your friends. Stay tuned for more exciting conversations in IEEE Talk. And remember, control is not just about systems, it's about influence. Everything seems stable until the system proves otherwise. So ask yourself, who or what is really in control? Thank you for watching and صحة عيدكم.